An hour ago, she was out on the highway, probably on her way to see Grandma. But something has happened. She's lost her cool. Our guess, the air conditioning quit. It could be the compressor, or any number of things. If it's the compressor, let's find out how it works and what it does. It looks a lot like a small two-cylinder gasoline engine, but without spark plugs or a carburetor. However, when the clutch engages, cool, low-pressure refrigerant vapor rushes through the suction side at a pressure of about 30 pounds per square inch. The pistons take this vapor and compress it to nearly 200 pounds per square inch. Controlling this suction and compressed refrigerant flow is a valve plate with reed valves. Discharge reed valves have stops to limit their lifting action, while suction reed valves do not. The initial factory oil fill is about 10 to 12 ounces. Yet, after only a few minutes of system operation, this drops to about 6 to 8 ounces. Now, here's how this oil lubricates internal parts of the compressor. Oil system pressure is developed by pump rotors, which are driven by a small shaft indexed to the crankshaft. A continuous stream lubricates both rod bearings and the rear bushing journal. However, it is only when these two drilled holes align with the bushing slot that the front gas seal gets a spurt of oil for lubrication and cooling. Piston skirts, piston pins, and cylinder walls are splash lubricated by oil thrown off by the crankshaft counterweights. Now, compressor oil level is critical, and here's how it's checked. When temperature in the service shop area is above 85 degrees, set the air conditioning controls at the AC position, blower at high speed, and open the car windows. However, if shop temperature is below 85 degrees, set the control panel at the max AC position, temperature control lever at full heat, blower at high speed, and close the car windows. This provides a heat load on the evaporator. But remember, in this mode, some vacuum-operated water valves will open when the temperature control lever is moved, while with others, you'll have to temporarily disconnect and plug the vacuum line in order to get hot water flowing through the heater core. With all controls properly set, we can now get the oil out of pockets in the system. To do this, run the engine at a fast idle for 15 minutes. This circulates the refrigerant vapor at a rate high enough to sweep most of the oil back to the compressor sump. Then, with the engine stopped, slowly discharge all refrigerant into a well-ventilated area or through an exhaust eliminating system. After waiting about 10 minutes to let the refrigerant boil off in the sump, pull the fill plug and insert a dipstick so that it contacts the bottom of the sump. The oil level should show between 1 5/8 and 2 3/8 inches. If there is too little oil, add an ounce at a time until the correct level is reached. On the other hand, if you find too much oil, use a syringe to adjust the level. Refrigerant vapor, flooded with far too much oil, permits large drops to get under the reed valves, keeping them from closing properly. They may bend, crack, or break. You can pinpoint damaged or broken reed valves with a gauge set. Compare these normal inlet, suction, and discharge pressures of a good compressor with the gauge readings you'll get when there's a damaged or broken suction reed valve. Notice that inlet and suction pressures here are much higher because some of the vapor being compressed is forced back into the suction side of the system. For the same reason, discharge pressure is lower than normal since the vapor is not fully compressed. Not only is refrigerant flow reduced, but the vapor gradually becomes hotter and hotter because the heat it carries is not transferred to the condenser. This causes the pistons to overheat, and they either seize or the compressor becomes noisy. Incidentally, don't blame the compressor for noisy operation until you check for loose mounting attachments or loose drive belts. If the compressor must be removed for overhaul, first remove the clutch hub locking bolt. Then thread a proper size cap screw into the hub to force the clutch hub off the tapered shaft. The clutch field coil and drive key are easily removed. Clean all external compressor surfaces with an approved solvent, then remove the EPR valve. Cylinder heads and valve plates come off next. You may have to tap at these lugs to separate them from the cylinders. After the bolts are removed from the front bearing housing, carefully pry it off. Tap the front gas seal plate out. Then remove the outer O-ring seal. As the sump separates from the case, the pressure relief spring and check ball come out too. Save the oil so that it can be inspected. Mark the connecting rods and caps to ensure reassembly in their original position. After removing the pistons, take out the oil pump rotors and drive shaft. Keep rotors together. Discard the O-ring seal. Now the crankshaft comes out easily. With the main housing stripped, remove the gas seal and discard. Then wash the front bearing in clean mineral spirits. Re-oil, then check for roughness or flat spots. If you detect such a condition, press the bearing off. However, before you install a new bearing, make sure there are no signs of scoring on the rod journals or bushing metal wiped over the rear journal. If so, also check to see if the bushing has turned in its bore. If you find it turned or scored, do not attempt to replace it unless your shop is equipped to handle precision rebore and honing. If the crankshaft journals and bushing appear okay, then slide the shaft into the bushing. A slight amount of clearance is considered normal. Apply refrigerant oil to the new front bearing, then using a sleeve, press the bearing onto the shaft. Wipe the cylinder walls. Then look for signs of scoring, heavy scuffing, or unusual wear. If okay, coat the walls with refrigerant oil. Piston skirts must not show signs of scoring or scuffing, and rings must move freely. Bearing surfaces should have no dull gray or dark streaks visible on the bright aluminum surfaces, and no pitting or chipping. If only new rings are needed, installation is quick and easy. There's no set position for the ring gap. Reed valves should not be bent or creased, yet reed lift up to 0.010 of an inch is considered normal and has no bad effect on compressor performance. Our inspection is over, so now let's get it all together. The thrust washer goes over the rear journal. Carefully slide the new gas seal assembly up against the front bearing. Make sure the tangs are indexed. With the micro-finished surface of the new seal seat plate facing towards us, tap the plate into position. Install a new housing outer seal. Then wipe with refrigerant oil. Pull the housing in evenly by torquing the cap screws to specs listed in the service manual. Next, install the pistons. On RV2 models, the cutout sections of the heads point towards the rear of the case. Bearing caps go on exactly the same way they were when removed. Bearing cap screws must be torqued. Install a new oil pressure relief ball, then the spring, and a new gasket. Install a new gasket on both cylinders. The valve plates, new cylinder head gaskets, Then the heads. Torque bolts according to your service manual. Install the oil pump drive shaft. Rotors are next. The chamfered side of the outer rotor faces inward. A new seal is vital. Make sure the compressor turns over freely. Installing the clutch assembly is simple. Nothing difficult at all. However, make sure the key slot is aligned with the drive key. Now, if bits and pieces of metal or other types of contamination are found in the refrigerant oil, the system must be flushed thoroughly with liquid refrigerant. To do this, here are some of the important service steps. With the compressor installed, use a short piece of hose to bypass the receiver dryer and connect the special valve core removing and installing tool to the discharge muffler service port. Immerse the expansion valve thermal bulb in 125-degree water to ensure a wide open valve. It will take about 5 pounds of liquid refrigerant to flush the system properly. Procedure will differ whether the system has a standard expansion valve or an H valve. Additional details are in the reference book. After reconnecting all lines, add 10 to 12 ounces of new refrigerant oil. If the system did not need flushing, then only 6 to 8 ounces are necessary. After you vacuumed the system, then charged it with the correct amount of refrigerant, customers have different ways of showing their appreciation. For a service job, well done.